April of 2020, Facebook and Amazon independently called me and said, we just sent everyone home and we don't know what to do. I got to track everyone's life going through a camera and see what makes the smartest teams. Smart teams are relatively small. It's hard for the 101st person on a team to make it any smarter. Smart teams are diverse. You want to bring together people that truly have something different to bring to the table, but who also have complementary touch points with people that already exist. And then the last one is very flat hierarchies. What's the point of having all of this diversity of knowledge and insight and thought process if no one's getting listened to? Literally, you can model it as the more equitable their turn taking, either online in the camera or in the document, the smarter the team gets.
Welcome to the Work for Humans podcast. This is Dart Lindsley. There are many ongoing dilemmas and fears surrounding the future of AI, but renowned theoretical neuroscientist and artificial intelligence expert Vivienne Ming sees it differently. For over a decade, she has harnessed AI to enhance human potential, designing systems to treat her son's diabetes, predict manic episodes in those with bipolar disorder, and reunite orphaned refugees with extended family members, among many other initiatives. Vivienne has emerged not only as a leading scientist in the field, but also as a passionate advocate for using AI as a powerful tool to unlock human ability. Vivienne is the co-founder and CEO of the think tank Socos Labs, as well as chief scientist at Dionysus Digital Health and the Human Trust. She received her BS in cognitive neuroscience from the University of California at San Diego and her MS and PhD in psychology at Carnegie Mellon University. Her research has been showcased on TEDx, the Financial Times, The Atlantic, the New York Times, BBC Radio 4, NPR, and other outlets. In this episode, Vivienne and I talk about her diverse background in AI and research, AI's qualitative advantages over humans today, and how AI can predict and influence individual success in children and adults. We also discuss meta-learning and perspective-taking, building stronger social networks with AI, the moral limits of markets, and other topics. All right, if you enjoy the insights on today's episode, as I'm sure you will, be sure to hit that subscribe button so you never miss out on future episodes. Okay, now I bring you my conversation with Vivienne Ming. Vivienne Ming, welcome to Work for Humans.
It is lovely being here. Thanks for the invitation.
I have so many questions about AI, some of which nobody's ever been able to answer for me, and so I'm super excited to have you on the show. You have such an incredibly extensive and diverse background. I think some of these questions may be unanswerable, but I want to start asking them. So the first one, and I've asked this of others who weren't able to answer it for me. If you were to draw a Venn diagram, and one circle of it is what humans can do, and one circle of it is what AI can do, I'm super interested in the part of the Venn diagram that AI can do that humans can't. In particular, a lot of times what technology does is it's a quantitative difference in what humans can do. It can do it faster, but it's the same thing. But are there things that AI is doing today that are qualitatively different from what humans can do?
Yeah, there's a couple of important words you used in there that are worth re-emphasizing. What can computers and AI do today? And I like that emphasis because let's just dispense with it. What they can do tomorrow, we do not know. I know I'm supposed to be here as an expert. And yes, you have the good fortune of being able to interview the one person in the world who's always right about everything. But at the same time, some things are unpredictable. And I don't mean super rare. It's very unlikely that in the next 10 years, a supervolcano is going to erupt and exterminate all life on Earth. But we could actually give that a number. I can't tell you whether or not, or even how, super intelligent computers, intelligent in the way we are, but vastly exceeding us, will come from. So let's just set all of that aside and we can dive into it. I love science fiction and we can talk about that ad nauseum. What can they do today that we can't? And I think this may sound minor, but it's worth understanding because if nothing else, it's the name of a really great science fiction series, which is the three-body problem. There are certain kinds of patterns in the world which we simply cannot deal with. It takes an enormous amount of effort for us to go beyond tracking 1, 2, 3 causes of things in the world. When a longtime professional executive recruiter looks at a resume, they're really looking at about 3 things, at least on that first pass. When a chess master is looking at the state of a board, they're largely just considering 3 or 4 possible moves. Where old-fashioned deep blue, as you're saying, qualitative difference, might be looking at tens of thousands of possible moves. And a modern reinforcement learning-based AI like AlphaGo is somehow mashing both of those. The amazing pattern ability of those chess masters with the number crunching of a deep blue type computer. All right, so that's impressive, but is it really functionally different than what humans can do? And I think one of the most exciting areas isn't the chatbots we interact with on a seeming regular basis nowadays, as they constantly seem to be asking me to write emails for me. It is things like deep neural networks for weather forecasting or to predict the movement of bodies. So beyond that supervolcano, we can also wonder if we're going to hit by a life-ending meteor. Well, we are tracking the ones we're specifically tracking, but they're interacting with all of these heavenly bodies out there, and it's really hard to predict exactly where they're going to go. These things can do that in a way and at a level that human beings simply cannot. Or at the very least, the quantitative difference is such that it truly is a qualitative difference.
Yeah. It's where basically quantity is a quality all its own, which is that you don't even need to identify what variables need to be taken into consideration. You have a massive set of data that no human being could ever parse in a lifetime, potentially. And sure, you could probably find some correlations between one variable and another, but first you've got to identify what the variables are. But no, instead what we're going to do is we're going to look at all the variables at the same time, and we're going to find the signal out of all the noise.
And when you look at AI through that lens, and I don't mean to only put it in physical systems, but human beings just add a whole new layer of complexity to everything we might be interested in. So if we look at it through weather forecasting and scientific research, we look at it for material sciences, the ability to predict when new metallurgical techniques will succeed or fail, the ability, for example, of AlphaFold to predict all these potential protein structures. Those don't actually mean those proteins exist in the world or that they're interesting, but they're there. And it's on a scale that we simply can't even come close to. But it's worth noting, again, it's not just that we could only have done a few of these by hand, but now it can do thousands or millions. When you're really thinking not what a computer-assisted human could have done, what can the human brain do? None of these computations are achievable by our brain. We simply are no good at dealing with that kind of scale of data on one side or chaotic data on the other. And these systems are shockingly good at dealing with that sort of thing. Shocking, I simply say, because chaotic systems, forgive me if I'm nerding out for the wrong audience here, but chaotic systems are deterministic. They follow rules. They are in theory fully predictable, but you can't predict them because they're so full of nuance. And these models are able to deal with it to a level that's useful for us to leverage.
So what was the first time when you were working in this field and the field surprised you? When an AI surprised you?
Some things were surprising just because I was getting introduced to the field. So, oh, wow, I thought I was going to be a traditional wet neuroscientist and monitor the neurons of the Mongolian hamster, which are gerbil, which has a very similar auditory system to us for God knows what reason, because it's much smaller than we are. And then unsolicited, a professor of mine recommends me to work at this place called the Machine Perception Lab, and they have a real-time face tracker in 1999. And my honors thesis could tell the difference between a Duchenne and a non-Duchenne smile, a real and a fake smile off of raw video. And wow, that was, as a science fiction nerd in the early part of my life, building something, a machine, with equations that I understood and had programmed in by hands that could understand, seemingly understand, something so human when someone was genuinely happy versus when they were just politely smiling. That was a wow. In retrospect, given what I know about these models and what they're good at and not, oh yeah, of course it was good at that sort of thing. But that really got me, and it got me hooked. It totally changed the trajectory of my career.
So I assume you were less surprised than most of us when LLMs, well, at least from my perspective, seem to just jump off the table and start running around the lab. Were you surprised by that at all, by that step forward, or did you just absolutely see that coming?
It's been a progression. I think what surprised me was not that we reached that level of capability. Natural language processing, as that broad field might be called, was heading in that direction. Several things co-occurred, both scientifically and technologically, that really allowed for some of these breakthroughs. For a nerd like me, the best documentary series ever was actually made in the 70s called Connections. So as long as you can stand too much polyester and bell bottoms, and occasionally some slightly out-of-date sociological theory, this British series would start in the year 7000 BCE and trace the invention of the plow to what would have been the cutting edge of 1973, the Arecibo radio telescope in Puerto Rico, or the transistor, or the launching of the Apollo program, or these all along the way. It feels so inevitable, and yet this is a historian and a journalist take on it. These events weren't really inevitable. They were quirks of moments in history. Might they have happened differently through a different timeline? Sure, but they wouldn't have ended up the way they did. Why did Germany become an industrial power? Because people were looking at quinine as a treatment for malaria, but it didn't turn out to work very well. But it turned out it kind of works as a dye for purple colors. But the British weren't that interested in it, and so the Germans took over the research, and just these quirks of history led to transformational parts of the world we live in today. So, understanding that so many things came together from about 1999, when I entered this field, and neural networks were falling out of favor. Not AI as a wish, as a dream, but neural networks themselves, but a series of things. A guy in the body of Jeff Hinton just keeping the faith that if we could just make these models bigger and figure out some technical limitations, it would still be the big breakthrough. The scale of image data and sound and text to make it happen. Well, my own field of theoretical neuroscience, what we were trying to do was understand, why does our primary visual cortex process visual information the way it does? Why does our auditory cortex or our motor cortex, why is it structured? Well, we're all theoreticians. We don't want to just sit around and stick wires into cats. We want to take mathematical principles, and to be able to test those principles, we need 1 million photographs. So we could see, how do our mathematical principles actually describe these images? And then, of course, we needed processing power that could handle all of this at the same time. So let's just go back to, say, 2006, when Jeff Hinton's first deep neural network, what was called a deep belief network, had this crazy success in being able to recognize the objects and images and just beat the pants off of all the other text in a regular competition that was going at the time. When it first happened, I remember when I saw these models and I thought to myself, well, we're all trying to build bigger models right now. Why is this particular architecture going to win? There doesn't seem to be anything excitingly new, but as soon as all those three pieces came together, the success rate of those models took off. After that, a lot of things seemed inevitable. Surely a natural language version of these models would take off. Surely sound-based versions of these models, speech recognition, things like that. But, at that moment, from about 2000 to 2006, all of this stuff was on a downward trajectory. The number of times the words neural network were getting published in papers in our fields was disappearing. Now, of course, everything dominates everything in the space.
This is the sort of thing I ask just because I'm curious, not because it's related to the show. But is it just that compute caught up, that compute made neural networks work?
Compute caught up not because of scientific computing and not because of the needs of Google. Compute caught up because existing computers weren't good enough for games. Games have gotten so computational. The literal physics, the physics simulators and games were so computationally intensive, they needed their own math coprocessor, but that was no longer good enough. And so not NVIDIA alone, but them in particular said, all right, we'll start making these chips that are essentially little supercomputers on a chip. But initially, they were all essentially just math supercomputers on a chip. And I remember when the first person at our institute at Berkeley got a hold of one of these and said, what if we could spread out all the computation of our stuff onto one of these chips? And so instead of relying on the regular processor in our computer, we could run 100 computations in parallel on this whole parallel computing thing. So it's not so much that we were all waiting for this. We were all building these giant models already. It took a month for them to run. And then when this thing came about, because people wanted to play Halo and Call of Duty, clever people thought, well, God, maybe we could use this too. So it really was the scientific need of these nerdy brain researchers trying to understand the statistics of the world, the computational need of scientific computation, but also the industry was already independently working on better processing so we could have more fun.
I love this idea of just like legions of gamers producing a market that drags the whole technical community into this new era. It's fascinating.
Yeah, I mean, the claim I've read is that the entire steam engine really was born simply out of the fact that people were mining coal just for warmth, and the mines were filling up with water, and it was expensive to pump the water out of the mines. But you had all this coal and this water, and the steam engine that had been around since Roman times. Only in that context was it practical to build. Was it economically practical? But we got so good at building it to pump the water out of mines that pretty soon we're mining coal to feed the steam engines everywhere else in society. And that's what these coprocessors, these distributed computing systems were in this context.
I want to get into the applications related to work. Now, there's different ways that this conversation could go. One way is AI going to take my job? And we may possibly get to that. But what I want to get to is the work that you've done in how AI might transform employment and education. So within employment, and education, there are key things that you've applied it to, like, for instance, assessment and predictive analysis of future performance of people and team performance and things like that. So let's pick one of those examples and let's dig into it. What's your favorite?
Gosh, which one is my favorite? My favorite right at the moment, simply because it's the hot new baby, is understanding what makes the smartest teams. But obviously, that work grows out of trying to understand individuals. And then that came out of my trying to understand students. It all flows one to another.
Let's talk about the sort of application for students and how that plays out.
I have a pretty colorful educational history all by myself. And if I were to simplify it down to what would people have fed into an algorithm, you would have seen that I had really high standardized test scores and probably high cognitive ability at some level. And that would have said, as it effectively did, oh yeah, she's going to be very successful. She should get to go to a very fancy university. Except it would have been totally wrong, because I flunked out of that university and then ended up homeless. So all this raw cognitive ability that, whether we're really in touch with it or not, we as individuals have a lot of appreciation for. Much more so than hard work, even if the outcomes are the same. We have a real bias in favor of potential and raw talent over hard work. Well, it turns out if all you have is some smarts and very little else, that's not enough, as my life was a testament to. So when I had the chance to do my life over again, and I'm studying brains and I marry someone who's studying education, we really wanted to take that somewhere and say, all right, what could AI tell us, machine learning models, tell us about what predicts success in, say, a young child's life? And I think on some level, it's worth noting that I can go through a long list of the things that our models told us and how we approach that work, and they won't surprise you. For one thing, yeah, intelligence is predictive, particularly of academic success, but people with larger working memory spans, as just one very concrete example of a way of measuring intelligence, they earn more, they have better health outcomes. Turns out they aren't terribly happier than everybody else, but in many ways, they have things that we would all cherish if we had access to them ourselves. But when we started to look more richly at this, not what is the correlation of all these sorts of things with going to an elite university, which then tells you, yeah, well, you need really good grades. Well, of course you do, because that's what they filter for. That's literally how they admit their students. So of course they all have good grades. What causally distinguishes the students that had good grades but didn't get in from the ones that didn't? And what I'm not interested in, or at least not for the purposes we're discussing right now, are things that are outside of that student's control. It is a legitimate social policy issue that someone from one zip code and someone from another have wildly different health outcomes, even though they are, let's say, for our purposes, indistinguishable. And in fact, I think Raj Chetty's work saying, he has this very prominent research line on what he calls lost Einsteins. And if you really look in detail at his data, you see what I thought was the most shocking finding there, which is a poor kid in the highest math quintile is slightly less likely to earn a patent in their lifetime than a rich kid from the lowest math quintile. Now, some of that may speak to truly unearned privilege, or the complement of that, which is potential, which is simply going unrecognized by society. I have a whole body of work in that space. But it turns out it's also fair to say that that rich kid probably has a bunch of qualities that the poor kid doesn't. Qualities largely inherited from peers and from parents that aren't necessarily about grades or raw cognitive ability. So if I want to build an AI model, let's make it very grounded. If I wanted to build something that can leverage GPT or Gemini and pulls in some deep neural networks and says, tell me who this kid is, so I know what they need as a student and where they could be going in their life. What you would find is cognitive ability matters, but so does emotional intelligence, resilience, conscientiousness, emotion regulation, executive control. These are turned out, if anything, to at least be equally important to cognitive ability. But the stories can get complicated. Social skills, perspective taking, communication skills, these are also hugely predictive and, interestingly, almost completely uncorrelated with emotional intelligence. So we can begin to look at a constellation of these things that AI begins to reveal that are not part of our education system. They're not measured by any existing standardized exams or even the formal exams within a school. I think they're implicitly there, maybe in the minds of really good teachers. They're role modeled in the houses of kids that have the good fortune of being born into a house where the parents have these already. It should be what our education system's about, and it isn't. But the positive note here is, done well, and there's a huge asterisk next to that, AI can play a transformative role in doing this kind of modern assessment.
Importantly, it could be used different ways. I mean, one way to use it is I'm going to use it to decide who goes to college. I'm going to use it as a screening tool. Or it could be used to decide what we're going to teach and what we're going to teach each kid and how we're going to build up some of these things that might be teachable in such a way that the student can be more successful instead of as a screen. And it's not, I'm going to teach you a skill like algebra or something like that. It's one of these other attributes which they sound more like ways of approaching the world or ways of interacting with the world.
Well, what's exciting about it, and for the sake of accelerating our conversation here, I'm just going to throw down this term that we use at Socos Labs, which is meta-learning. Learning how to learn. What are all of the things, if we just use that as an umbrella term to capture all the things that are measurable? I am a hard number scientist. I work on a lot of very squishy things, like long-term life outcomes, but I'm only satisfied if I can measure something. They are highly predictive. I'm not interested in things which correlate strongly. When you start talking about humans, there are 1,000 spurious correlations for every meaningful causal relationship. So you have to take this stuff really seriously. Where do we see, for either theoretically or proven experimental research, plausibly causal relationships with long-term life outcomes? And lastly, they're intervenable. They're changeable. Because if they're not changeable, if something was 100% genetic, that's interesting to me as a scientist, but it's not interesting to me as an educator because there's nothing I can do about it. Maybe it's context. This person has this, they don't have that, so I need to take that into account. That's worthwhile. But if I can't change these fundamental things, then it doesn't excite me nearly as much. And when we take these models and we apply them, and if no one's ever heard me do this reveal before, we in the end got to apply this to about 122 million people. In this case, not kids, but adults, working professionals around the world. And when we begin to apply these models, we see it's not the skills you claim on your resume. It's not whether you learned algebra at a specific age. It is these meta-learning traits that are really predictive. Again, I believe causally related, provably in many cases, like with working memory and resilience are two examples of demonstrably causal relationships, that if you can go in and intervene on these and change them, increase working memory span, brutally difficult, but very doable early in a child's life, and increase resilience, also difficult, because the only way you can increase resilience is for people to go through experiences of failure, and nobody wants to do that. But there are resilience interventions that have been designed and deployed in the world. People go through this. It takes time. It's experiential learning. Unlike factorizing a polynomial, I can't just give you a worksheet and say, go learn it. You have to really go through the experience of failure and then the experience of finding success out the other side. It takes time. It takes effort. It's messy and ugly. If you're looking for a 3-week job retraining program, this is not it. But this is the thing that changes someone's life. Because once you have changed, like a standard deviation increase in working memory span is an additional $30,000 a year in earnings. A standard deviation increase in the psychological construct of resilience is a similar earnings, but it also comes with health gains. It comes with, interestingly, educational gains. And then even things that feel less connected to a lot of our technologicalized world, like perspective taking. Software developers that are higher in perspective taking write better code. They have fewer errors. Cyclometric analysis of their code, very fancy terms, shows that they do better work. This is what matters. And I will end my little soapboxing with the following. None of this means that we have to abandon teaching people how to do things, concrete skills. The wonderful thing is you can really multiplex this together and think we're working on this 10-year-old's understanding of a kind of a complex idea, algebra. Well, that complex idea is also a little hard. Let's do a resilience intervention worked through this algebra training. Now we have to explicitly be intentional about both sides of that so we can actually get the full benefit. How do I know this child at this moment? Because our model said, right now, this child is plastic, a fancy smancy term for sort of ready to learn. They're showing plasticity in their resilience. This is the time for them to experience it, which adds a level of complexity, right? This kid's doing algebra and resilience. This kid over here, maybe they're not ready for algebra. Why do we require every kid to learn this thing at the exact same moment in their life? But at the same time, maybe they're not really plastic on the emotional side, the resilience, but maybe there'd be a really good perspective-taking intervention would be successful, or an analogical reasoning, or what have you.
You've used the word perspective taking, and it's not a term that I know. Is it like empathy? Is it like seeing from other people's perspectives, from other people's views?
It's like empathy, but there's a couple of constructs. Again, this is nerdy stuff, but there's a couple of constructs, grit and empathy, that to my taste are somewhat backward defined, which is to say, Angela Duckworth's wonderful persuasive research on grit is based on, let's start with these people that complete SEAL team training and then work backwards to a test that predicts that they will succeed. Rather than starting at a more mechanistic level, what is a latent or a hidden quality people possess that, if modulated, goes up and down? So clearly grit and resilience are very similar, interrelated. Resilience is the R in grit. But when you get nerdy into the construct details, I prefer the constructs that are defined with respect to the individual and are forward-looking into the impact they'll have, rather than the ones that are backwards defined. So empathy, I have found hard to work with, but by its very definition, it is predictive of life outcomes because it's used to identify people that are sensitive to the emotions of others. But it's more like theory of mind. Perspective taking gets at a little theory of mind. Do I have a model of you in my head? Regardless of whether I share your feelings about the world, am I getting the way you're thinking about it? And I've just found that to be a more utile construct.
That makes a lot of sense. And so, I don't know if we're skipping a step or not, but I would like to talk about teams, and I'll tell you why. Is because companies have known for a long time, or at least thinkers who talk to companies have known for a long time, that teams are really the thing. That teams are the unit that actually gets work done. And yet, so much of what we do is focused on individuals. And it's been kind of an unsolvable thing that it's like we know it's true. It's just too complicated to think about. And it's too complicated to predict. People try, but it hasn't been very successful.
Here's where we can come back to our earlier conversation. What can AI do that simply, qualitatively, humans can't? They can deal with these big, messy, nonlinear, complicated systems. Of course, there is a world in which master teachers and the most elite of managers truly understand holistically their team, how they fit together, the way they play off of each other. A great coach understands that they don't necessarily want a superstar for their new forward. They want the person that's going to complement the rest of the team and lift everybody on the team. In fact, in sports, there's this great measure, the plus minus of just Who cares whether you scored a basket? Who cares whether you got a rebound? Do we score more points when you're in the game than when you're not? That's such a complicated idea. In a game, it's really easy to measure as a statistic. But in the real world, that is a complicated idea. And if you go beyond just, well, they score more points, really, we're talking about if I hire them, if I invest in their human capital and we're looking to develop this skill versus that skill, where is my gain here? This truly is something that AI is better situated to help us with. And I'll be clear. Every time I use AI, feel free to, in your mind, think augmented intelligence. I'm not that interested in fully autonomous systems. I want to make better people, including better managers. And this, I think, is a great area for AI to come in and say, what is the missing ingredient? Where is the complementary diversity that's going to make my whole team better because they're both bringing something we don't have and complementing existing strengths?
Okay, so I'm going to just tell you something that's missing in the objectives of most research regarding teams that could potentially be solved. What most research into teams has looked at is how much value does the team create for the company? Productivity, whatever. What they don't look at is that, plus how much value does the activity of the team create for the team members themselves? And if we really, really want to look at how bright is a team burning, it's the total value created by the team, not just the value created by the team for the company.
Yeah, it almost gets into, again, a nerdy space from a totally different field, which is economics counterfactuals. In a different world where this is a slightly different team, what is the optimal makeup? In fact, when I think if we want to marry together teams with what we already talked about, how do we measure students? How do we identify the things that they need to learn, and not just learn, but grow in themselves? Well, let's take that a step further. Part of the biggest influence you'll ever have on a young mind is through role modeling. You want to be a better parent? Be the person you want your child to become. That is far and away the single biggest impact you will ever have on them. And the side benefit is you get to be that person. What an amazing thing. You're better, and so are they. But it turns out peers have huge effects. There was just a paper based on some Raj Chetty data showing that the big predictor of a lot of academic outcomes later in life is the employment, not of the child's parent, although that is a predictor, but the employment of their peers' parents. And so a kid moving into a neighborhood with low unemployment rates, high university attendance, even if their family misses some of these magical secret ingredients that more privileged families are getting for free, you pick it up. It's being too offhand to say you pick it up osmotically, but really there's a degree to which it's just the peer role modeling that's going on around you, and kids are extremely sensitive to it. Turns out, so are adults. Now, we're not going to have a magically huge effects on, say, cognitive development when you're already in your 30s, but when we look at the things I already talked about before, like resilience and perspective taking and analogical reasoning, we still see potent peer role modeling effects going on all throughout people's lives. So these aren't just how do you change a little kid who's still in school. These are recipes for how you continue to grow throughout your life. And if you are a thoughtful organization, how you can engineer that growth across a team. Now, I've got two little stories to share. One is a fairly provocative question asked by a very, very large company of about 130,000 people, which was, if we gave you full access to all of our internal data, could you tell us what is the single biggest predictor of productivity that we're not tracking? And here's where I get to be a mad scientist and look at data no one ever gets to look at.
The mysterious thing is productivity data, which can be very challenging.
It is a mess. I'm a nerd. I don't recommend my methodologies for an HR team at all for a variety of reasons, but I like to be able to share the findings nonetheless because they point to what we all ought to understand. So I've got that story. And then I've got April of 2020, and Facebook and Amazon independently called me and said, we just sent everyone home and we don't know what to do. No one knows what to do, right? We haven't had the entire world working remotely before. And the research on it is disjoint, and it's about very privileged workers that earned the right to occasionally work from home, or very low-skill workers about conspicuous monitoring and how you prevent shirking. No one's really saying what happens when everyone's doing it. And the two things they really wanted to know about were inclusion and innovation. And it turns out those were very similar stories. So in this second story I have to share, I got to track everyone's life going through a camera and see what makes the smartest teams. And so these are both interesting, and they really tell very separate stories. Totally, they're not contradictory, but each one takes in a different. One is the punchline is about purpose, and the other punchline is very grounded, but it's about what we have been leading up to, which is how the composition of a team drives its collective intelligence, and how you can build that up and how you can erode that and what it plays out. So is there one you want to start with?
Oh, I'm very excited about, just because of how the data was collected and the idea that we can collect data from essentially online interactions in meetings and what we discovered there. Because that's always the question. Are we going to get enough data to do the crunching of it? And that's such an incredibly rich source, potentially.
Interestingly, it is starting my career as an academic and saying already from day one, my field of theoretical neuroscience was this field that was hungry for data. And then when I entered and became an entrepreneur and started companies, I realized I could trick venture capitalists into funding my experiments. As long as I made them some money, they would pay for me to collect 122 million people's worth of data. Of course, the other side is I also had to give those 122 million people some value for the data. But a lot of my work really has come down to, and even now my purely philanthropic work is really, where can I get a real world data set? Not a lab data, but real data of people actually interacting. Well, as you can imagine, if you've got Amazon and Facebook, you got a lot of data. So I began researching this question and watching everyone. And it's not just about our lives going through cameras. It's also shared collaborative documents where I can see in real time people going in and out, exchanging, making comments, making edits. It was fascinating. And some of the things emerged right off the bat are totally in line with the fairly rich and full existing literature on collective intelligence. Smart teams are relatively small. It's hard for the 101st person on a team to make it any smarter. Smart teams are diverse, but though we had some interesting nuance here. So I mean diversity in almost any way you could imagine. Socioeconomic diversity, expertise diversity, but I don't want to shy away. I also mean gender, race. You want to bring together people that truly have something different to bring to the table. But interestingly, in looking at that data at scale, huge numbers of people, we saw something I hadn't seen in the research literature before, which isn't just that diverse teams were smarter. Teams that were too homogeneous were actually dumber than the individuals would have been in isolation. Something about the internal skepticism that we would have had for ourselves in isolation begins to fall away when someone's very, very much like you begins to yes and your ideas. That may not shock everyone if you've ever spent time with a group of people that are overly similar, essentially failing to ask the tough questions of each other. But what's interesting is that finding is they aren't doing it knowingly. Their brain is treating the other person's idea almost like it was your own. So it gets to bypass all of the walls of skepticism. And so one of the findings we had is the optimally smart teams are in this balance between diversity and trust. And you want it as far over on the diversity side as you can get, without losing the trust entirely. You want sparks, no fire. We extend the diversity notion then a little bit by saying what you really want is a term I already threw out earlier, which is complementary diversity. You want members of the team that bring something truly unique, but who also have complementary touch points with people that already exist. And that was really important. And then the last one is kind of an intuitive, if you really work through it, which is very flat hierarchies. What's the point of having all of this diversity of knowledge and insight and thought process if no one's getting listened to? If one dude makes all the decisions. So it was really fascinating. And again, has been replicated in a lot of other really interesting, I call this computational social science, being able to take AI and do traditional lab experiments, but on all of Dropbox collaborative documents. And in there, you can see so clearly there could be a Nobel Prize winner and an undergraduate intern. There could be this SVP of engineering and a summer intern. But when they were collaborating on that document, all of that hierarchy fell away. And when they were the domain expert, they took the leadership role. And literally, you can model it as the more equitable their turn taking, either online in the camera or in the document, the smarter the team gets. And so you have these three ingredients: complementary, diversity, relatively small teams. 3 or 5 people, definitely smarter than one, but you don't get a lot of benefit from getting bigger. And then this flat hierarchies, this shared leadership and turn taking. With those 3 ingredients, amazing things happened. And you've got a question, but I've got where AI plays a role coming up next.
Well, my question is, you're pointing out that you want them teams to be diverse, but not too diverse. And it occurs to me that the boundary of where too diverse is must also be an attribute of the team. And so some teams may have an attribute that allows them to be more diverse without creating conflict.
Exactly. So I talked about how, admittedly, I didn't go into any of the exemplar research we've done in this space, but I just said from on high, I'm a very smart person. Trust me, AI is good at making measurements of individuals. Well, we started thinking, all right, given all these things we see about what make the smartest teams, generically speaking, can we build a model that looks for that in a team and actually looks not just at a team, but at a community? Could be a whole company, it could be a school, could be a literal community. And it says, here's the existing social network, the matchmaker's role, the AI, where to make and break existing social connections to maximize the intelligence of the community. And it turns out, importantly, this is a dynamic process. Take, for example, that team that's too similar. Obviously, during ideation, they need to get broken up. They need some independent ideas. And it's hard enough, given their similarities, for them to come up with them independently. But when they're talking to each other, it's impossible. So for the next month, they don't get to talk to each other. And interestingly enough, we can throw in, as nodes in our little social graph, we can throw in GPT and Gemini. We can throw in access to the library or the company records and dynamically gate access to maximize the intelligence of the total community. Now, here's where this becomes even more complicated, because it turns out we have an additional finding. What makes smart teams? I told you. What makes the smartest community? This takes it to a whole other dimension. I'll give you the punchline first rather than all the research behind it. In the smartest community, the majority of people are wrong the majority of the time because they're exploring.
So, first of all, I just want to say, I don't know what community means in that sentence, because it could be teams of teams, or it could just be a bunch of people in a mungy kind of...
It could be all sorts of things. I'm using hopefully intuitive language, but it inevitably falls down. So when we start in our analysis, we actually starting with communication data. So let's say I've got a company's email and chat data and so forth. Well, forget the org chart. Who actually talks to whom? That's the social network we actually care about here. who's collaborating in a document. Two people are closer together if a message started with one person quickly and inevitably finds its way to another person, even if they aren't directly connected. And they're far away if it almost never goes from one person to another. Well, because we're working with real world data, we don't need to send pretend packages out into a social network. We can watch actual messages diffuse, use natural language processing to say, yeah, an idea started over here and it took this amount of time to get over here. Here's the actual social network of this community. Community just being all those employees that were in our original data set. Now we can say, this is a functional team and this is a functional team. People could be part of multiple functional teams. It makes the analysis more messy, but it's the real world. That's the way things work. And those people that are parts of multiple are really interesting because, of course, they're little hubs that link independent teams together. So let's have that be a rich part of our understanding of the intelligence of teams, is the role of those connectors. But we also have the content of what they talked about. When are people evolving novel ideas? This is something computational social science can do that we could never have realistically done before. Watch an entire large-scale company think. Where are new ideas being born? Where do they die? Which can be bad, but it also can be good. Where do they grow, mature, turn from an idea into a practice? We can model and measure all of those things. And our one action point for our Matchmaker AI is, in watching all of this happen, it gets to go in and turn on and off social connections to maximize not just the local novelty of ideas, but it's a bit of a theory of innovation here, how those novel ideas are matured into practices and then adopted throughout an entire community. And it turns out it's a multi-stage process and it's complicated, and it would be dramatically hard for an individual human to monitor this. In theory, possible, but really tremendously difficult. And these AIs can do it at scale and really transformationally.
I'll tell you, I would absolutely pay for the ability to know who I need to connect to inside an organization to get an idea to go, to get an idea to take off.
Yeah. And I can remember when I first started thinking about this many years ago, a startup I was involved in that never went anywhere called Conga. The tagline I had for our company in our head is not who do you know, like LinkedIn. It was who should you know. So the original model I ever did on this was in 2012, where we built these models to figure out, let's say I'm a neuroscientist. We have this giant annual convention called Society for Neuroscience. And there's 50,000 people there. And the vast majority of them do research that has nothing to do with my weirdo little theoretical neuroscience field. But somebody there is the right connection for me. Not just in a grounded way of, oh, they published a paper that it has a connection to yours, but also there's that complementary diversity. They're looking at it differently than you, but actually it turns out you have a similar personality and you'll connect. So in our matchmaker model, we also take into account these personality factors. So those people that are hubs, I want to understand them because maybe I've got two functional teams that are working on similar ideas. That's good. That's not bad. Far too many people would look at that and say, oh, you're wasting money. Two teams are working on the same idea. Whereas I haven't explained why, but my earlier contention is, yeah, but you need multiple teams. You need, in a productive way, for the majority of them to be exploring dead-end ideas or wrong ideas. But when we have all these teams, eventually, when one of them reaches that dead end and the other's still progressing, which members of the team are we going to connect together? Why pick at random? Pick the two people that are going to click and are going to create a real exchange.
That makes so much sense to me, which is a company as sort of a search algorithm. It needs to test a lot of surfaces. It needs to find out which one is going to be productive. I had one person on the show, Kentaro Toyama, who wrote a book called Geek Heresy. And what he found is, in his work, he worked for Microsoft and he worked in India. And he was in the business of taking technology out into different parts of the world. And what he found was that technology on its own is insufficient. He called it the law of amplification, which is that when you introduce technology into an environment, it can only amplify the social structures. And so great social structures, it does a lot. And I'm being a little vague here about social structures because it can be skills, it can be norms, it can be a lot of different things. But if you just drop technology into an environment that can't use it, it does nothing. And so one of my questions is, and I think this is a really hard question, what do we need to develop in order to have AI amplify us in a good way?
I'm going to chastise myself first. I was speaking just then with great enthusiasm about what's possible, not what's likely, what's possible. I have these models. They can do these things. Will they do these things released into the wild? And in that sense, I agree with the thesis of his book. In fact, I'm going to make it even more provocative here. Technology is inevitably inequality increasing, not because it has to be, but because inevitably the people that need it the least are the ones that will benefit the most. So this sort of the same things I spoke about earlier with respect to individuals. We can proxy this with socioeconomic status, but it's this richer meta-learning. People that are rich in meta-learning, new technologies, very much including AI, show, let's call it creative complementarity. They aren't just speeding up your day because they read emails for you and summarize them. What a useless use case. They are speeding you towards a better version of yourself. I would never in a million years allow GPT, Gemini, Claude, any of them to write a single throwaway tweet for me. I treasure my voice. In fact, in a different version of our little interview here, I'd be saying, in a world in which all the world's knowledge is free in your pocket, then it is not that knowledge that makes you valuable. It is your unique perspective on that knowledge. It is what you would do with it differently than literally anyone else in the world. And the cruel thing, to my mind, is this has literally always been true. It's just without AI in the world, there was still work to be done in just putting people out into the factory line and sort of churning even a sort of cognitive factory line of crunch these numbers and file this paperwork, make these diagnoses, do this routine contract work. But we don't really need that anymore. And pretty soon it won't be we don't need it. It just won't be cost effective to have humans doing it. So with that deprofessionalization going on, what's left? Well, I don't want to be either dystopian or utopian about it, but if I wanted to give it a really more than just a silver lining, what's left is everything. It is the infinity of the unknown. If the known is the fundamental domain of AI, the unknown remains our playground. And the unfortunate thing is, neither our education system nor our systems for workforce are set up for that. We are still live in a world in which people are judged by this way that they can answer well-posed questions. And no one can answer these questions better than Claude or Gemini can. At least not within the vastly broad scope of most human beings' jobs. The elite of humanity still outperform these models in interesting ways, but pretty much we've just massively deprofessionalized 99% of the workforce. Doesn't mean the jobs go away, but deprofessionalize those jobs. And because of that creative complementarity I mentioned, and your other interviewee, I think, emphasized, the rest, that last 1%, takes off. And the amazing things they can do with AI, not letting it read their emails, do the exact opposite. I'm writing a chapter for a book right now, and I take that chapter and I say, Gemini, you are my worst enemy. You are my nemesis. For my entire career, you have found every flaw in every experiment I've run, every mistake I've made in an essay I've ever published. Here's the new chapter of my book. Find every place where I'm wrong and thoroughly explain to me why. I'm not speeding up my writing. I'm slowing it down. I call this productive friction. If we can use these tools to orchestrate them to make us better, rather than to automate ourselves away. When I interviewed for grad school, I said I wanted to make cyborgs. And this dynamic interaction between the AI tool and the human explorer, that's the cyborg I'm finally getting the chance to build. If we just automate it ourselves away, that is a dismal future, which, again, might benefit an elite few that are very naturally going to go use these tools in much more creative ways. But almost all of commercial AI are these trite and trivial product offerings. That's why I'm so excited about the behind the scenes stuff, being able to model chaotic systems, being able to do unique drug discovery or computational social science. Hey, I'm curious where great ideas come from. Let's read every single dissertation ever published and process the context in which great ideas are created. I could never have done that before, and now that is something I literally get to do today.
A part of what you're calling out is that productivity is often measured in time, and it should be measured in something that's a lot harder to measure, which is the quality of the outcome. And in this case, the novelty of the outcome, the novelty and the accuracy of the outcome.
As the benefit, I have the best job in the entire world. It turns out it's a very expensive job to hold, but when you put out a shingle that says, I will help people for free, as long as it's about people, you get to work on so many cool projects. And occasionally, they have some real practical effects. This very fancy light bulb behind me treats Alzheimer's. Another one of my companies developed the first ever biological test for postpartum depression. Again, fundamentally impossible without machine learning to be able to analyze someone's constantly changing epigenome to make that prediction. But those are transformational changes in the world, and they started purely as philanthropic projects. And people get to be alive because of this.
Ooh, I didn't even know that we could measure epigenome activity. That's really interesting.
Yeah, you start with the huge breakthroughs in genomics, but then you layer on top of it this whole other messy world. How does your genome change over time?
These two questions are related, and so I'm going to kind of munge them together. The first part of the question has to do with the moral limits of markets. What's so interesting about your work? A lot of things are interesting, but one of the things that's super interesting about your work is that you've been right up close to people who want to pay for AI. So you can see what the market's asking for. And sometimes you take the work and sometimes you don't. And so there's this question of, are markets going to drive the right use? The second question is related. If you were a legislator and you were thinking, could I make a rule that could make all this work better? What would that be?
Well, as I said at the top, as the person that has all the right answers about everything, I fortunately can answer all of your questions. Let's start with the challenges of markets. I am a deeply practical person. I'm sort of a realist idealist. I dream about a better world, but I want to know literally in a grounded way, how do we get there? And so a lot of the political theory of today is scary because it seems to have abandoned the idea that there's a better world on both sides, to be honest. Utopianists seem to think there's a better world, but only if you let an iron fist crush you. And it doesn't sound very utopian, but it still seems to be the theme of the day. And the dystopianists think nobody can be trusted. They're both so negative about humanity. But again, I want a grounded way forward. So I actually largely believe in markets. I have bigger issues with capital markets than the core of market theory. But as a resource allocation mechanism, markets are amazing. But what makes them really amazing is when their underlying assumptions are met. And a few of those assumptions are obviously some degree of shared information. There's no monopolies or monopsonies going on, which does not describe the real world very well. But if we're talking about the price of bread, that policymakers should really not get involved because markets are actually genuinely good at that. Where do traditional markets fall down in ways that interest me and directly touch on what we've talked about? Innovation markets. Innovation hasn't happened by its very nature. There isn't a track record. Innovation also tends to be very sparse. If you're a nerd, it's very long-tailed. There's a whole lot of failed innovation and a very small number of successes that capture almost all of the returns. So, how does an optimal market, even in theory, function in an innovation market? It turns out for the individual players, the right thing to do, we can confirm this both in theory and in human practice, the right thing to do is as soon as someone has found a good enough answer, everyone else herds around it. Maybe that's why, in my earlier bad-mouthing of VCs, the idea that a VC just wants to hear how you're Facebook for X or Tesla for Y is because they get that. And interestingly, movies are kind of similar. They're so expensive these days, so much effort and man hours goes into creating a movie. We don't want to take a risk. These are very sparse. There's only a small number that are successful and they capture almost all the returns. So this is the perverse thing about a traditional innovation market. The right individual solution for the players is the wrong solution for the market. If the purpose of the market is to maximize our collective intelligence, discover those best ideas no one's ever come up with before, it turns out a classic market return. You put your bets down where you think there's going to be a good idea, and then we all share how right we were with those bets, induces herding. And herding is pronouncedly suboptimal. When you ask the players of the real version of these games, we could run prediction markets. Did you explore the whole space of possibilities and ideas? And they say, oh, well, I mean, maybe not everything, but like 70 to 80%. In our analysis, they explore like 20 to 30%, but everybody explores the exact same 20 to 30%. Nobody's really exploring because they don't individually get anything back because they're probably wrong. So as soon as there's a good enough answer, stop and put all of your bets on that. So that's a space where traditional markets fail. But then we look at, what can you do? Are there changes in market incentives? Can we keep a market, but change the incentives? Whether we're talking about an implicit market, say, inside of a company, or a real market out in the world. And yeah, actually, in this context, there's one simple change you can make, which dramatically changes the collective intelligence of the market and a variety of other features that are really exciting and inspiring. I'm going to call this incentive structure, borrowed from another thinker, minority opinion, like minority report. In this case, there is a market. There's all these predictions to make about the future. You place your bets down just like you would have in a traditional market. But you only share in the returns if you were right when the majority was wrong. So you get nothing for investing in safe ideas because everyone's already there. So nobody gets a return. You only get a return if you took a true risk. You bet an idea that's probably wrong, but if it's right, it changes everything. That simple little change dramatically increases. Then people truly do. Collectively, 70 to 80% of the market space truly gets explored, both in theoretical, game theoretic models and in human experiments. So it's possible to change what a market can do in these more interesting, complicated cases. But we get to engage with, we've got to stop thinking about this massive, complex economy that we live in the world, or even just in America, for that matter, just Los Angeles. That's $1 trillion economy all by itself. It's not the farmer's market anymore. One person didn't work really hard picking a bunch of apples, trundled it down to the market, and their hard work is paying off. This is a very different world than that. And I think we need to understand markets in a much more modern way. And that would be what I want policymakers to understand.
I ask everybody at the end of the show something because I believe work is a product. It's a complicated thing, which I won't totally explain. And what I ask is, what do you hire your job to do for you?
Wow. so many different possible answers I can give to this. I'll give the most truly basic answer that I arrived at, let's say in about 1995, which is I decided I'd rather be alive than ending my life. And if my job is to live a life that gives other people better lives, then that was the realization I came to. Maybe I'm a failure. Maybe I'm never going to be happy, but I can still live a life that makes other people's lives better. And the wonderful thing is, 10 years later, I discovered, wow, I do get to be happy. And it was a transformational realization. The other thing is, I am endlessly curious about people and the messy, complex systems of the world. So no one who works with me would be shocked. I have never found a business idea that I couldn't make worse with a little heart. I do my jobs because someone will be helped, and I get to scratch this itch of being the first person in the world to know some secret fact about the universe. And then I get to share it. I get to feel good about what I do, and I genuinely enjoy it.
What does your job cost you?
Literally about $1 to $2 million a year. Less literally than that. I like a concept of work-life synergy rather than work-life balance. I think of the fact that for about 10 years in a row, 2020 notwithstanding, I was not home on my own birthday to spend with my family. I'm very much a family-focused person. I'm not very social. But every time I went out on one of those trips, when my kids were younger, they're earlier now, I wrote a little short story that said why it was more important that I was helping someone else than being there helping them. And a lot of that short story, some of these were easy to write. Like, my son has autism and type 1 diabetes, but he's an amazing, creative, brilliant kid. And he's come to understand, even given the wild unfairnesses of his life, he will have a vastly better life than the majority of kids in the world. And so he's proud that he gets to share me with other kids in other places, and that we get to work on these sorts of projects. And in that sense, I get to be the person I want him to grow up to be. But I'm not going to pretend there's no cost there. It sounds so fancy that I get to fly around the world and tell people how they ought to run their companies or their countries or work on these amazing projects. But I'd rather be in my lab or with my family. And finding that synergy where one makes the other better is something I really look for in life.
Where can people learn more about you and your work? And what are those books that you're working on that are on your back wall there?
You can find out about me at socos.org, SOCOS.org, where I have a newsletter and people can reach out if they want to just ask for help. Because again, that's part of what I do. But also, let's say they are one of those people that doesn't balk at the idea of paying a big speaker's fee because they know I'm going to use it to work on one of these projects. Go to Socos, learn about a lot of things you and I have talked about.
And that's spelled SOCOS.org.
Yes. By the way, if you want to learn about some of my other companies, there's DionysusHealth.com or Optoceutics.com. Dionysus is the one working in postpartum depression, and Optoceutics and Alzheimer's. And our new nonprofit working on the idea that people shouldn't have to choose between a life-saving diagnosis or a transformational educational experience and the right to the privacy of their own body and their own data. It is The Human Trust, thehumantrust.org. Go check it out. We believe AI acting solely on your behalf should be a constitutional right. There's another thing for policymakers to factor into their thinking about AI. But all of that said, if you are curious about how to robot-proof your kids, or the tax on being different, or we never got around to the story on purpose, but small sacrifices, I am literally this month finally finishing I've got 2 draft chapters to polish up, and then How to Robot-Proof Your Kids is in my publisher's hands. Given the state of the publishing industry, God knows what that means for a release date, but I will have finished. It's grown to more than 400 pages, and it's a mix of stories working in the space of AI, but all centered around the idea of a very human-centered approach and what it truly means for humans to be successful in the world that is changing. So that's the first one up. The Tax on Being Different is very autobiographical, but it's combined with using AI to understand what it means to be different in the world. I'm a very different person, and as you heard, so is my son. And then finally, that story about the giant company wanting to know the single biggest predictor of productivity inside their company. Turns out the answer to that is strength of purpose. And so the subtitle of that book is The Science, Economics, and Story of Purpose. And it's an amazing little book that also includes a chapter titled Why Do Assholes Rise to the Top? And if any of those interest you, although the book's delivery dates have not been set, if you subscribe to our newsletter, we'll make them available for early order to the members first.
Thank you very much for coming on the show.
It was a huge pleasure.
Thanks for joining me for another episode of Work for Humans. If you enjoyed this episode, please give us a 5-star rating wherever you listen to podcasts. And share the show with one person you think would get value from it. Believe it or not, this really helps us grow the show and reach more people who want to build the kind of work that people really want. As always, thank you to my producer Jason Ames at Ninth Path Audio for his insights into content and his high standard for quality. Final note, the opinions shared here are my own and not the views of Google or Cisco Systems. Thanks again for listening. See you next time.